Let's talk about reproducibility and replication. These are two of the most critical statistical issues facing the medical literature today. But what do they mean and why are they important? If you follow popular writing about science, you might see headlines like this: most science research findings are false. Here's how we can change that. Or, is there a reproducibility crisis in science? So if you're seeing headlines about how most science is false or how there's a crisis, you might think that there's a major problem underlying the medical literature. And to understand that problem, you first have to understand what these statistical terms mean. So in this lecture, we're going to cover what is reproduce, what is replicate, and what is a false discovery. So first, we need to understand what are the different parts of a scientific study. You start with a population that you might be studying. Then you might ask a question about that population and make it really concrete by focusing on a single hypothesis. You design an experiment to study that hypothesis, and somebody conducts that experiment. They collect data. Then they have a plan for how they analyze it. They hand that over to the analyst, who analyzes the data and produces code and estimates of the different parameters that you care about. And then finally, you make some claims based on the data, on the estimates that you've observed. So these are the different decision points in a particular scientific study. And what we want to understand is, what do reproducibility, replicability, and false discoveries mean in terms of these different decision points? So let's focus on reproducibility first. Imagine I run a study and I collect data, and then I analyze that data and produce some estimates, and I make some claims about that data. What it means to reproduce that study is you take all of the exact data you got from the original study and all of the exact code you got from the original study and just hand it to a new analyst. That analyst should be able to run your code on the exact same data and get the exact same results. While this seems like a really simple idea, it's actually very hard to do in practice because it's difficult sometimes to get all of the data due to restrictions on privacy or difficulties with data sharing, or because the code might have changed a little bit, or some of the software underlying that code might have changed. So sometimes you don't exactly get the same answers when you rerun the same code on the same data. So even at this low level, you get a little bit nervous if you don't get the exact same answers every single time. In terms of replicate, that's a slightly different thing where you do the exact same experimental design focused on the exact same hypothesis in question, but now you hand that design over to a different lab and they rerun the study and collect new data, then analyze it in the same way and see if you get a similar answer. Now with reproducibility, you expect to get exactly the same answer when you run the same code on the same data. With replication, you don't actually expect the exact same answer because you've taken a new sample of data. So there'll be random variation, new patients were collected, and the answer might be slightly different. But you hope it's at least close to the original answer that you got. A false discovery is the thing that people actually care about. So this is where you've made a claim in your scientific paper, say for example, a particular treatment has a particular effect on an outcome. Then that claim could be true or it could be false, and we only have the data to back up that claim. If it's a false discovery, then it's a claim that we've made that's actually wrong. And so we would like to know something about the rate at which the discoveries that are happening in the medical literature are false. One of the most popular papers about this idea is in this paper, Why Most Published Research Findings Are False. This is a simulation study conducted by a professor, and in the simulation study, they're looking at what are the conditions under which, if everybody in the scientific enterprise operated under those conditions, you might get most published research findings being false. The simulation study is interesting, but the title has definitely caught the imagination of lots of people who use this as justification for saying most research findings are false. But there's actually relatively little quantification of how many research findings are actually false. In this paper, we considered an estimate of that science-wise false discovery rate, or the rate at which discoveries are false across the medical literature, using p-values in published papers. This study has a lot of limitations, but one of the things it does is produce one of the quantitative estimates empirically of what rate discoveries are false in popular medical literature like The Lancet, JAMA, New England Journal of Medicine, and so forth. And we got estimates that were in the range of 20% to 30% false discoveries, higher than what you would expect given the statistical models used, but certainly not everything being false. That being said, because of all the caveats about this paper, we actually don't know for sure what rate medical discoveries are false. And in fact, we might be okay with some rate of false discoveries. If you plot false discoveries on the x-axis and true important discoveries on the y-axis, a field like physics, where most of the discoveries are made in mechanistic ways, might make relatively few false discoveries, but also make a relatively limited number of true discoveries because the system is limited. Meanwhile, biomedical scientists might be making many, many more discoveries because they have many more options of things to study, but they're also making more false discoveries. So the question is, Do we want to ratchet back the number of false discoveries we make and also maybe limit the number of true discoveries and important discoveries that we make? This is a question that the field has to grapple with, but it's related to the definition of being a false discovery, which is different than being something that's reproducible or something that's replicable. Now that we have these definitions, we'll consider the tools that we can use to measure whether something's reproducible or replicable, as well as what are the consequences in terms of human behavior.